All right, so our instructions today are find the inverse of each function, then graph the function and its inverse. So to find an inverse of a function, what you do is, well, first instead of g of x or f of x or whatever it is, let's call this y, and then we're going to swap the x with the y. Okay, so now it's going to say x equals, actually I'm going to write this over here, x equals negative 1 plus 1/3 y. So you switch the x and the y because that's what inverses do. They switch the x's with the y's. And then once you've switched it, now you solve for the new y. All right, so we're going to get y by itself is your goal. Right, so this y needs to be by itself. So we need to move this negative 1 out of there. So we're going to add 1 to both sides. The x plus 1, they're not like terms. So you just write x plus 1. And then you bring down the 1/3 y. And now, how do we cancel out a 1/3? Well, we multiply by 3. You multiply by whatever's on the bottom to cancel it out. So if you multiply by 3 over here, you're going to have 3x plus 3 is equal to y. So this is your inverse. Now to write that it's an inverse, we go back to the g of x notation. And so instead of y, we'll put not g, but g prime of x is equal to 3x plus 3. Okay, so that little symbol there, that little apostrophe, um, indicates that this is the inverse of g. And we call this g prime. All right, so there's our inverse, and then we just need to graph them. So I'll graph the inverse in red over here. So if I remember y equals mx plus b, so the b value is 3, so we start up there at y equals 3, and then the slope is m, which is 3. So go up 1, 2, 3, and over 1, go down 1, 2, 3, and left 1. So there, and I could continue that pattern again, is going to be our inverse graph. So then connect all your dots. And there's your inverse graph. I'll graph the original in blue. So the b value here is the negative 1, and then the slope is 1 over 3. So go up 1, right 3, and then go down 1 and left 3. And then connect all your dots. Okay, there you go. Now, what you should always notice is that the two lines will always be, or should always be, reflected across that green dashed line. So if you see a reflection, like if you folded your paper across that green dashed line, the two lines would meet. That's would be reflection, and that should always happen if they are in fact inverses. Okay, so they should always meet somewhere on that line. Now it doesn't have to be at a perfect point. Like these don't meet um, at a at like negative 2, but they would meet on the line. Okay, if they look like number 2, what I would do is separate out this divide by 5. So this is the same thing as negative 2x over 5 plus 10 over 5 is 2. So if you just make them all look like that, that'll make things a little bit easier. But I'll do this one here with you again. So remember, swap the x with the y. So it's going to say x equals negative 2y over 5 plus 2. Now we're solving for x. So you just subtract that 2 out of there. Oops. So then we got x minus 2 equals negative 2y over 5. So we have a 5 to get rid of and a negative 2. So if you multiply by the 5, let's multiply both sides by 5, that's going to be 5x minus 10 is equal to negative 2y, because those 5's cancel. And then divide everything by negative 2. Divide by negative 2. So that cancels the negative 2's there, and then we have 5 over negative 2 or just negative 5 over 2x. Negative 10 over negative 2 is going to be a positive 5 equals y. So there is our g prime, and I want you to write it like that. G prime of x equals negative 5 over 2x plus 5. Then once you've got the equation, got the new function, now you just graph them. So we have a b of 5, a slope of negative 5 over 2, so we're down 5, 1, 2, 3, 4, 5, and to the right 2, 1, 2. 1, 2, 3, 4, 5, 1, 2. So there is the graph of our inverse function. Now just graph the original. And so our b is 2. I'm going to graph that in blue again. So the b is 2. So start up at y equals 2. The slope is negative 2 over 5. So go down 2 and to the right 5. And I'm going to go backwards. And then draw my line. Yep, and there we go. And notice they do cross right on this line here, that diagonal. So yeah, it looks good. If you have any questions, let me know. But that's the idea. You swap the x with the y, then solve for your new y, and then graph both lines. If you have a double or a fraction like number 3, just like number 2, just split it up into 2 fractions. I think that'll be easier for you. You can do it either way, but it'll be a lot easier to graph when it looks like this. Remember, you divide both sides by 2, or both pieces by 2 is what that means.